So we continue from where we left yesterday. We were calculating the observabilities. We started from primary output and we moved towards primary input. Right? We defined the initial observability as 0 for the primary output. So x, y, z तीनों के लिए red में हमने 0 लिखा था. Then we propagated to level 4. Level 4 के input पे we observed the values, that is we calculated the observability CO. CO was at any input, let's say COA was given as the observability at the output plus the CC, if I'm, what was this, CC 0, non-controlling value. The controllability to put other inputs to non-controlling value. ठीक है, +1. Observability में yes, +1. So here we got 3. When we calculated this as observability of output, which is 0, plus controllability to put other input to non-controlling value, ये हमारा क्या है, OR gate. OR gate का non-controlling value is 0. So CC 0 of the other input is taken, which is 2. So 0 plus 2 plus 1, that gave me 3. Similarly, I calculated it till this point, till the second level. Now crossing the first level or propagating it back to the inputs, इस वाले वायर का कितना होगा observability for the input of NOT gate 1? This will be the observability of the output, which is 3. दूसरा input है ही नहीं इसमें, therefore that would be 0 and plus 1. So I should get the observability on this wire as 4. Similarly, we'll calculate the observability for the input of logic gate 2. इसका हमने अभी output क्या नहीं निकाला है. So calculate the output observability for this wire. This will be given as 3 का output observability, which is 0, plus इस वाले wire का observability to put the value equal to 1, because this is AND gate and the non-controlling value is 1. तो 1 के लिए CC1 is 2, so plus 1, 3. So this also has the observability of 3. Now calculate the observability for the input of logic gate 2. That would be this 3 plus 0, since no other input, plus 1. So that means 4. Now try to move to the primary inputs. ये जो हमारा 114 है, this is directly seen to A, और A का जो fan out है, वहां पे मुझे वैल्यू मिल रहा है 118. Therefore the minimum will be taken. Therefore the value of observability at input A would be 4. नीचे वाले fan out से 4 आ रहा है, ऊपर से 8 आ रहा है, so I'll take the minimum. So the observability at A is 4. What about B? B is fanning out to this arm, top arm. इसका observability is 8 और नीचे वाले का observability is 6. So I'll again take the minimum. So the observability will be written as 6. Hence we have all the controllabilities and observabilities for every wire. Now which one to initialize? The one which is having the easiest control and easiest observability. That should be the fault that I should consider first. Right? तो सबसे पहले मेरे को कौन सा लेना है? Observability तो पीछे से हम देख रहे हैं. Right? Controllability we are reading from primary inputs. So as we move forward, the complexity increases, the controllability increases. It becomes more and more difficult. So we'll choose the one with the highest value so that हम उसको एक बार में fault ले ले, and उससे जो test pattern आएगा, whatever other faults that test pattern considers, we'll eliminate all those faults together for the next step of simulation, right? This is about the controllability and observability of combinational circuits. Things differ slightly when it comes to sequential controllability and observability. If you look at the circuit is almost the same except that कि जो X output यहाँ पर आ रहा था मेरा, that X is now we are getting outside this D flip flop, right? और ये जो D flip flop का output है, this becomes my secondary input. So no more I have C and X, but they are tied up together through a D flip flop, right? Similarly, जो Y था, that is given back as input to these wires. So B and Y, they are shorted through a sequential, it's through a flip flop. So now I have this sequential circuit now. इसकी अब मुझे controllability and observability निकालनी है. The formulas almost remain the same except for eliminating that +1 factor. Because it is a sequential circuit which works on clock edge, so I'll have to analyze for more than one cycle to get the stabilized value of controllability and observability. Therefore, every time adding +1 within the cycle will unnecessarily give me a large value. So while we are calculating sequential controllability and observability, we drop that factor of +1. Rest formula remain the same. Additionally, we have the D flip-flop for the sequential circuit. So D flip-flop की controllability देख लेते हैं कैसे निकालनी है. The controllability for 0 to be set on Q. 0 कब आएगा इस Q पर? एक तो इनमें सब में reset होता है. Every flip-flop has a reset line, right? अगर नहीं दिया हुआ है reset, so we take the value as 0 always. So if there is reset, the value will come out to be 0 जब system जब flip-flop reset हुआ हो और उस पर एक clock edge आया हो. Clock edge आना मतलब I should read CC0 as well as CC1 if I am talking of positive edge also. If I am talking of negative edge triggered flip-flop, then it should be initially CC1 then CC0. However, both of them should exist. Therefore, my formula says output will be 0 only when या तो मेरा सिस्टम रीसेट हो गया या तो फ्लिप फ्लॉप रीसेट हो गया या उसका D वैल्यू ही 0 है, right? So if the system is reset, then when the output will be 0, जब reset equal to 1 हो और clock edge आ गया. So this gives you the first case. CC1 is reset, CC1 for clock plus CC0 for clock, the first case. Second case में output 0 कब होगा? Reset नहीं हुआ है, लेकिन my D value is 0, which is propagated at the clock edge. So the second case would be CC0 at D, the controllability that wire D has the value 0 plus the controllability of the clock. So CC0 of clock plus CC1 of clock. ठीक है, इन दोनों में से जो भी मिनिमम होगा, because either of the two cases can give you the output value 0 on Q, right? तो हमने कॉम्बिनेशनल सर्किट में देखा था जब दो केसेस होते हैं, so we take the minimum of the two cases. So here I will take the minimum of the two cases. ठीक, अगर रीसेट नहीं है, then this first case will be eliminated, right? In the circuit that we will be considering later, I have not placed any reset line, right? Reset line अगर नहीं है तो ये value 0 हो गया, खाली clock आने पर 0 होगा नहीं, so I should not consider this first condition. So only value for CC0Q would be CC0 at D plus CC0 of clock plus CC1 of clock. ठीक है, ऐसे ही sequential controllability at output, to put the value equal to 0, I should consider the sequential controllabilities now. तो जहां मैंने कल की टेबल में CC0 लिखा था, अभी वो हो जाएगा SC0, SC 1 for sequential calculations. So I will have the same formula except that CC1 की जगह I'll consider SC1, sequential controllability. So I'll have the minimum of sequential controllability 1 for reset. Sequential controllability, this should be SC. SC1 for clock, SC0 for clock. Second case, SC0 for D, SC1 for clock, SC0 for clock. और sequential controllability निकालने के लिए for D flip flop we add 1 क्योंकि एक clock cycle के बाद sequential value आया है, right? So only for sequential controllability of the D flip flop we have this factor of 1. बाकी सब में से हमने 1 हटा दिया. C0 ऑब्जर्वेबिलिटी एट D, ये तो हो गया कंट्रोलेबिलिटी. 1 के लिए क्या होगा? सेम थिंग एक्सेप्ट दैट कि अब मेरा यहाँ पे ये जो इनपुट है CC1 फॉर D हो जाएगा क्योंकि आउटपुट 1 कब होगा? जब D का वैल्यू 1 हो. रीसेट से 0 हो जाएगा आउटपुट. सो रीसेट की कंडीशन नहीं निकालनी है मुझे. इनफैक्ट आई विल हैव CC1 एट Q given as CC1 at D plus the clock edge. So CC0 clock plus CC1 of clock. ठीक है. ऐसे ही SC1 क्या होगा? This would be SC1 of D plus SC0 of clock plus SC1 of clock. There would be no condition for reset. ठीक है. Then you have observability defined for the inputs. Input कौन कौन से हैं मेरे इस सर्किट के, इस फ्लिप फ्लॉप के? D है, क्लॉक है और रीसेट है, राइट? सो आई हैव डिफाइंड द observability for D, reset and clock. D का क्या होगा? D की observability will be given as the output observability plus the clock edge plus a reset. So CC1 of reset. Reset होना चाहिए. Sequential controllability, I should use the sequential observability. I should use the sequential values. So SO of Q plus SC1 of clock plus SC0 of clock plus SC1 for reset. ठीक है. Reset के लिए वापस से output observability plus the clock edge. तो CC0 CC1 ये रहा क्लॉक एज. रीसेट होना चाहिए. सो CC1 फॉर रीसेट प्लस CC1 ऑफ Q क्योंकि आउटपुट पर 1 रहा हो. ठीक है. सिमिलरली द सेम वैल्यू विल बी रिपीटेड ओनली फॉर सीक्वेंशियल वैल्यूज. द सेम फॉर्मूला विल बी रिपीटेड. सिमिलरली फॉर क्लॉक, क्लॉक के लिए द फॉर्मूला वुड बी गिवन एज ऑब्जर्वेबिलिटी. क्लॉक में चेंज कब हो रहा है? जब CO ऑफ आउटपुट इज कंसिडर्ड प्लस द क्लॉक एज इज कंसिडर्ड हियर. उसके साथ में CC1 ऑफ Q एंड CC0 ऑफ D. D इनपुट तो 0 है, आउटपुट अभी 1 है, तो यानी नेक्स्ट क्लॉक एज पर वो चेंज होगा, राइट? दैट वुड बी द फर्स्ट केस. द सेकेंड केस इज CC1 ऑफ Q पे 1 है लेकिन रीसेट 1 हो गया है. सो द आउटपुट वैल्यू विल कम आउट टू बी 0 नाउ बिकॉज इट इज रीसेट, राइट? थर्ड केस, रीसेट तो नहीं हुआ है लेकिन आपका जो CC1 ऑफ D is considered because now the input is D. D will be propagated, right? So sequential के लिए the same thing, same formula repeated, only the thing is we should have the sequential values. We'll look into these formulas when we work for controllability and sequential observability for sequential circuits, right? Initial value यहाँ पर हम सब wires की infinite मानते हैं. The combinational values are given in round brackets and the sequential values will be given in square brackets. हमारा बुक में ऐसा दिया हुआ है, right? We will be using in the form of table. Your Book does not show it as a table. उसमें पूरा theory लिखा है. It would be easy to understand through the table. So we'll use this table. Now, we initialized all these signals with the initial controllability and observability as infinity, चाहे sequential हो, चाहे combinational. Fine. Now we move with the first pass. First pass means सबसे पहले मैं controllability निकालूंगी. I'll move from primary input towards primary output. Then I'll calculate the observability. I'll move from primary output to primary input. Let us talk about controllability today. So in the first pass, I begin with the primary inputs. सबका मैंने initialize किया infinity, but now I work with the primary input A. Primary input A का initial क्या होगा? Controllability, what do we assign? 1 1. So combinational controllability is 1 1. A का initialize मैंने infinity किया, but in the first pass I give the value as 1 1. Sequential के केस में +1 नहीं करना है हमको. इसका मतलब इसका वैल्यू एक पीछे चलेगा initially. So the first value that we initialize for primary input for sequential controllability is 0 0. तो A का हो गया 1 1 0 0. ठीक है. This I write 1 1 0 0. बाकी सबका अभी infinity है. Now this 1 1 0 0 is seen here at the input of the first level. Right? So output of this NOT gate, which is B, I'll calculate the controllability, combinational controllability for B as previous. Combinational controllability क्या होता है? उसके inputs की controllability पे depend करता है +1. Right? So this we calculated yesterday as 2 2. Right? We had the formula here. आउटपुट की कंट्रोलेबिलिटी अगर एक इनपुट से सेट हो रही है, सो आई टुक द मिनिमम ऑफ द कंट्रोलेबिलिटी वैल्यू एंड एडेड 1. अगर सारे इनपुट को सेट करने पर हो रही है, आई एडेड ऑल द कंट्रोलेबिलिटीज फॉर इनपुट एंड एडेड 1. राइट? तो आई एम डूइंग द सेम थिंग. सीक्वेंशियल कंट्रोलेबिलिटी भी सेम हो गई. आउटपुट की वैल्यू 0 कब होगी? b इक्वल टू 0, जब इनपुट का वैल्यू 1 होगा. इनपुट 1 क्या है? 0. इसमें +1 करना ही नहीं है बिकॉज दिस इज सीक्वेंशियल, सो द वैल्यू रिमेन्स 0. सो SC0 is 0. SC1, when will B be equal to 1? When the input at this side, that is A, has 0 value. So I use the controllability CC0 or SC0. So SC0 is 0. I do not add 1. So this also gives me 0. Right? Let's talk about C. C depend किस पे कर रहा है? I पे. I is right now initialized as infinity everything. Right? So C will be all infinity. C will be 0 जब इनपुट की कंट्रोलेबिलिटी 1 वाली यूज करूं मैं +1, since I am right now doing the combinational controllability. So it would be again infinity. Let's do all the combinational first, then we'll do sequential, or we should do it together. Let's do it together. Sequential controllability for C. ऑब्जर्वेबिलिटी अभी आई नहीं. ये सीक्वेंशियल है, ये कॉम्बिनेशनल है. राइट? बेसिकली व्हाट वी आर ट्राइंग टू डू इज वी हैव टू रिड्यूस दिस सर्किट इनटू कॉम्बिनेशनल फॉर्म, क्योंकि हम फ्लिप फ्लॉप्स को एज सच टैकल नहीं कर सकते. देयरफॉर आई शुड वर्क विद कॉम्बिनेशनल कंट्रोलेबिलिटी as well as sequential controllability to know the actual difficulty in setting the value. So ऊपर वाला line is defining me CC0 and CC1. नीचे वाला line is defining me SC0 and SC1. Right? I should write it here. ऊपर I am writing CC0, CC1. Combinational controllability for 0 and combinational controllability for 1. The lower line, the lower row corresponds to sequential controllability for 0 and sequential controllability for 1. Right? I am moving from primary input towards output, so I am talking about controllability. Okay? Sequential controllability 0 for C would be SC1 for input without adding 1. So SC1 for input is infinity. So इसकी value अभी भी infinity होनी चाहिए. SC1 for C, this would be SC0 for I. So SC0 for I is infinity. So this is still infinity. Right? तो B का आ गया मेरा 2,2, 0,0 और C का आ गया all still infinity. Work for D. This is an AND gate. AND gate का output will be equal to 0 जैसे ही आपने एक input को 0 set किया. Right? So I should use the minimum वाला formula +1. So the output you say CC0 for D. The output D will be equal to 0 if I have any of the input set to 0. So I should choose minimum CC0. इसका CC0 is 2. इसका CC0 is infinity. So I should choose 2 plus 1. So that gives me 3. So CC0 for wire D would be 3. What would be CC1? Infinity. CC1 means D का value 1 कब होगा? जब B और C दोनों 1 रहे. So I should add the CC1 for B plus CC1 for C plus 1. So CC1 for C is infinity. So everything goes to infinity. So I should get this CC1 as infinity. Let us talk about sequential controllability at wire D. Sequential controllability SC0. SC0 would be the minimum of SC1 at the inputs. SC1 at the input, yes. So minimum value is 2. I do not add 1 now because I am calculating sequential controllability. So this becomes 2. SC1 कब होगा? यहाँ पे वैल्यू 1 कब होगा? जब दोनों इनपुट्स 0 होंगे, दोनों इनपुट्स 1 होंगे. दोनों इनपुट 1 मीन्स इंफिनिटी, ये वाला इंफिनिटी प्लस 0. So that gives me infinity again. So SC1 for wire D is infinity. 0. Minimum for sequential. This should be 0. So 3 infinity, 0 infinity. So D का मुझे मिल गया 3 infinity for combinational, 0 infinity for sequential, which will be seen here also due to the fan out, and the same will be seen at the third input of this NOR gate. So I write here 3 infinity for combinational, 0 infinity for sequential. ठीक है. D के बाद अब हम देखते हैं A तो हमें मिल ही गया 1 1 और 0 0. So level 3 के लिए I need E, है ना. D and D तो यही आ गया. E, I need E. E is taken up from the D flip flop, तो इसका infinity infinity ही रहेगा. So E is infinity infinity because this cannot be changed right now. I will change this in the next cycle. ठीक है? So E is infinity infinity for both the cases. So I got all the inputs here. This is infinity 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 infinity. Similarly for this gate at level 3, I got one value as infinity all and the other value is D, which is 3 infinity 0 infinity. Now I can evaluate for level 3. What will be the controllability CC0 for F? NOR gate है तो इसका non controlling value is 0. So when will be the output equal to 0? जब सब 1 हो. NOR gate है, so output truth table 0 1 1 0 1 1. This would be 1 0 0 0. Okay, so NOR gate के लिए we are calculating CC0. The output will be 0 when any of the input is 1. So I should choose the minimum of CC1 for the inputs. So इसका तो CC1 is 1, इसका infinity, इसका infinity. So I choose it as 1, add 1 since we are talking of combinational controllability. So F का हो गया 2. CC1 of F, आउटपुट F1 कब होगा? जब दोनों इनपुट 0 होंगे. Means you add SC0 for all the inputs plus 1. CC0 इसका 1, इसका 3, no, infinity. इसका 1, इसका infinity, इसका infinity. So addition will give me infinity. So the value CC1 is infinity. ठीक है? SC0. SC0 means कोई भी एक इनपुट 1 होना चाहिए but without adding plus 1. So what should be the minimum value? CC यहाँ पे SC1 is 0, SC1 is infinity, SC1 is infinity. So the minimum value is 0. Do not add 1. So the value 0 comes as it is. ठीक है? SC1. When both the inputs or all the inputs are 0. So SC0's का sum. SC0 is 0 plus 0 plus infinity. So infinity. Right? मेरे पास F का आ गया 2 infinity 0 infinity. This F I get here and I need G now. To define for level 4, I need the value for G. Okay, level 3 में अभी ये गेट रह गया. This AND gate का आउटपुट पे कितना आएगा? G is same as Z. फैन आउट है G और Z, इसलिए यहाँ पे Z लिखा हुआ है. This is same as G. G का कॉम्बिनेशनल कंट्रोलेबिलिटी 0. CC0 कितना होगा? AND गेट का आउटपुट 0 होगा जब कोई भी एक इनपुट 0 हो जाए. So minimum of CC0s at input. इसका CC0 is infinity. D का CC0 is 3. So the answer should be 3 plus 1, which is 4. So G के लिए CC0 is 4. How much is CC1? G will be 1 when all the inputs are 1. That is, you sum CC1 for all the inputs plus 1. So CC1 infinity plus infinity plus 1. That gives me infinity again. So 4 infinity will be for G. What is the sequential controllability? SC0. SC0 means minimum SC0. Minimum SC0. इसका तो SC0 is infinity. इसका SC0 is 0. So I should choose it as 0. SC1 क्या होगा? SC1 for both the inputs added together. So E का हो गया infinity, D का हो गया infinity, so the SC1 will be infinity only. So I analyzed for level 3, now comes level 4. So I work for calculating the controllability at H. What will be CC0 at H? OR gate hai, so non-controlling value is 0. So H would be 0 when both the inputs are 0. तो इसका मतलब CC0 of F plus CC0 for G. CC0 for F plus CC0 for G. That gives me 6 plus 1. So this gives me 7. Infinite H equal to 1 कब होगा? जब कोई भी एक इनपुट 1 हो जाए. तो मिनिमम ऑफ CC1 of inputs plus 1. तो इनपुट आर F and G. CC1 दोनों का infinity है, so the minimum value is infinity. Plus 1 gives me infinity, so 7 infinity. What about H? का sequential controllability SC0. SC0 of inputs added together. So SC0 for F is 0. SC0 for G is also 0. So दोनों का sum would be 0. SC1 आउटपुट 1, जब दोनों में से कोई भी एक इनपुट 1 हो जाए तो मिनिमम ऑफ SC1 ऑफ द इनपुट्स, सो दैट इज इंफिनिटी इंफिनिटी, दोनों का मिनिमम इज इंफिनिटी, सो द रिजल्ट इज इंफिनिटी. सो H मुझे पता चल गया, E मेरे पास ऑलरेडी है. व्हाट अबाउट I तो अभी इंफिनिटी इंफिनिटी ही है, यहाँ पे हमने लिया ही है, सो दिस विल बी इंफिनिटी इंफिनिटी. What about clock? Clock behaves as a primary input, so I should initialize it as primary input. तो जो A का वैल्यू था primary input का, वही वैल्यू clock का होगा. So combinational controllability is initialized to 1, sequential controllability is initialized to 0. So this is the first pass. But अभी मेरा D flip flop का output is neither controlled nor observed, because we have already seen there would be more cycles that will be involved for analysis of the output at D flip flop. This is first pass. ठीक है, अभी मैंने कुछ values update होंगी when I work out with the second pass. ये मेरी initial values है. Now I redo the calculations for second pass. ठीक है, A का वैल्यू पिछले पास में 1100 था, अभी भी सेम रहेगा because this is my primary input. So I initialize the I put the values as this in the second pass as well. No change will be observed in primary input. तो ना A में ना clock में. So I should rewrite it as the same values. ठीक है. Then comes B. B depends upon A only. A में कोई चेंज नहीं है, तो इसका मतलब B में भी कोई चेंज नहीं होगा. So B is same, or you can calculate it again. Depending upon A, you can calculate it again. Now comes C. C की वैल्यू कितनी होगी? CC0. CC0 means I should have I defined first. Okay, we should have I defined first. For the second level, I should have the output of D flip-flops defined first. So I'll evaluate E for this and I for this using combinational and sequential formulas. This will take time. We'll continue with the second pass tomorrow or in the next class so that we finish it later. Right? We'll keep on doing this updation until we get these controllabilities constant for at least 2 passes. तब तक हम इसको रिवाइज करते रहेंगे, बिकॉज अभी अब मेरा डी फ्लिप फ्लॉप शुड गिव मी एन आउटपुट. पहले मैंने इनिशियलाइज किया था इंफिनिटी इंफिनिटी. नाउ सिंस आई एम वर्किंग विद द सेकेंड टाइम फ्रेम, I should expect that the output has been moved with one time frame or one clock edge. So I'll calculate CC1, CC0 for I, which is the output of this D flip flop, and CC0, CC1 for E, which is the output of another flip flop. Then we use that value of I here so that I update the value of C. जब B सेम है C अपडेट हो गया तो D भी अपडेट हो जाएगा. D अपडेट होगा तो इन दोनों गेट्स पे भी अपडेशन होगा. Right? So the cycle goes on until the values become constant. Right? We'll try to do it in the next class. Till that time you have all the formulas. Give it a try. जब तक ये खुद नहीं करोगे नहीं समझ आएगा. There will be one question on observability and controllability calculation in your examination. ठीक है? That is all for today. This example is from Bushnell only. So you can refer the explanation in Bushnell if it is not clear here.